Hello everyone, welcome back to Bonza Academy. Today, we will be diving into functional requirements and template forms. In requirements engineering, it is crucial for analysts to comprehensively consider requirements from three perspectives: data, functional, and behavioral. Each perspective, when documented separately using suitable conceptual modeling languages, contributes to a holistic understanding of the system, aiding in its development. From a data perspective, the documentation focuses on the structures of input and output data, as well as the static structural aspects of the system's usage and dependency relationships in the system context. This perspective lays the foundation for the system's functionality. For example, a set of entities with attributes such as an order and order item. Each entity contains several attributes: name, description, quantity, and created date. The functional perspective plays a crucial role in documenting the system's behavior. It specifies which information of the system context is being manipulated by the system to be developed and which data is being transmitted to the system context by the system. This perspective also documents which data flows back into the system context and the order in which functions processing the input data are executed. For example, received data should be aggregated into 500 records and stored in document DB. From the behavioral perspective, information about the system and how it is embedded into the system context is documented in a state-oriented manner. It can be done by documenting the reactions of the system upon events in the system context, the conditions that warrant a state transition, the effects that the system shall have on its environment, such as the effects of the system analyzed, represent events in the system context of a different system. For instance, by successfully delivering an order, the item status should be changed to the delivered state. When specifying requirements, it's essential to consider different approaches, such as natural language, concept models, and hybrid methods. Each method comes with its own set of advantages and disadvantages. One of the key advantages of natural language is its practicality. It's the most commonly applied documentation form for requirements in practice, which means it's a familiar and accessible tool for all stakeholders. Unlike other documentation forms, prose does not require anyone to learn a new notation. It's versatile too, allowing the requirements engineer to express any requirement in a way that's easy to understand. The disadvantages of using natural language are that requirements might be ambiguous, and requirements of different types and perspectives are in danger of being unintentionally mixed up during documentation. In that case, isolating information about a particular perspective is challenging amidst all the natural language requirements. In contrast to natural language, the different types of conceptual models cannot be used universally. Special modeling languages that pertain to the appropriate perspective must be used when documenting requirements by means of models. Assuming the modeling language selected for a documentation task is correctly applied, its use constructively guarantees that the models created only depict information about the respective perspective. The models describe the documented requirements much more compactly, and they, therefore, are more accessible for a trained reader to understand than natural language. The most popular models for requirement specification are entity relationship diagrams, class diagrams, context diagrams, sequence diagrams, and state and activity diagrams. However, suitable documentation types are selected depending on the document's target audience, the perspective on the system, and the documented knowledge. Documents often utilize a hybrid approach, combining natural language and conceptual models to minimize the disadvantages of each type while leveraging their strengths. By integrating natural language and conceptual models in documentation, the advantages of both types are maximized. Natural language comments can improve models with additional context. In contrast, natural language requirements and glossaries can be summarized using models. This hybrid approach ensures that the documentation is comprehensive and clear, and effectively conveys the necessary information to the intended audience. Concept models are more or less standardized by organizations like OMG Group with UML and BPMN models, and the Open Group with Archimate. But what about the natural language that is presented in most specification documents? A set of generally accepted rules and recommendations exists to bring consistency to natural language in specification documents. Later on, we will delve into some template forms that can effectively structure natural language in specification documents. When forming requirements in natural language, requirement engineers should avoid certain pitfalls. Firstly, it is crucial to avoid using incomplete descriptions. This can lead to ambiguity and misunderstandings down the line. Secondly, non-specific nouns should be avoided, as they can make the requirements vague and open to interpretation. Additionally, incomplete conditions should not be used, as they may not provide a clear guideline for the development team. Lastly, incomplete comparisons should also be avoided to ensure the requirements are precise and actionable. Additionally, it is crucial to remember some key points for effective communication. Requirement engineers should exercise caution when using the passive voice in their documentation. Phrases like, "the order should be created," can lead to ambiguity and a lack of clarity in requirements. When employing universal quantifiers like all, never, always, rare, or a couple, requirement engineers should be mindful of the potential implications. These terms can lead to ambiguity or unrealistic expectations if not used judiciously and supported by concrete evidence. Nominalization, the process of turning verbs into nouns, should be approached carefully by requirement engineers. Converting long-lasting processes into singular events can oversimplify complex requirements and hinder effective communication between stakeholders. Let's look at a few rules examples that are commonly encountered in system development. First, look at nominalization. In case of a system crash, a restart of the system shall be performed. The terms system crash and restart may seem straightforward, but they each describe a complex process that requires more detailed analysis. This is where the potential pitfalls of nominalization and nouns without reference indexes can lead to ambiguity, underscoring the need for precision in our requirements. Another rule is nouns without reference indexes. For example, the data shall be displayed to the user on the terminal. In this example, ambiguity arises due to the lack of specificity regarding the data, user, and terminal. This ambiguity can lead to misunderstandings and, potentially, to a system that doesn't meet the user's needs. By adding reference indexes such as billing data, registered user, and the terminal he is logged into, the requirement becomes more precise and leaves no room for interpretation. So now we have a more specific requirement. The system shall display the billing data to the registered user on the terminal he is logged into. We mentioned universal quantifiers. Look at the example. The system shall show all datasets in every submenu. This example prompts the question, does this mean every submenu and all datasets? Moreover, inadequately defined conditions can lead to ambiguity in requirements. Consider the statement, the restaurant system shall offer all beverages to a registered guest over the age of 20 years. This leaves a critical aspect undefined. What beverages should be provided to 20 years or younger guests? Clear and precise requirements are not just a necessity, they are the backbone of successful system development. By avoiding misunderstandings and ensuring everyone is on the same page, we can all contribute to a smoother and more efficient development process. For instance, the restaurant system shall offer all alcohol-free beverages to any registered user younger than 21 years. All beverages, including all alcoholic beverages, shall be offered to any user over the age of 20. Finally, requirement engineers should avoid passive voice. An example of passive voice is, to log a user in, the login data is entered. This statement should be transformed into an active voice for clarity and directness. Here's how you can rephrase it. The system must allow the user to enter his username and password using the keyboard of the terminal. In this way, the action and the entity performing the action are clearly identified. In the previous module, we examined the user requirements template. If you skipped it or forgot, we recommend reviewing the module. Now let's explore a few practical examples of requirements formation for functional requirements. These examples will help you understand how our discussed theoretical concepts apply to real-world scenarios. The general possible flow is presented on the screen. Initially, you should determine the degree of legal obligation for a requirement. Commonly, requirements are categorized as legally obligatory, urgently recommended, future, or desirable. In practice, specific conventions dictate the use of auxiliary verbs to signify different requirement levels. Shall or must indicates a mandatory requirement that must be met. Should implies a strong desire for compliance, but is not mandatory. May suggests a course of action, while will does not imply a requirement. Next, a requirement engineer is recommended to determine the required process. At the heart of every requirement lies the functionality it outlines, such as printing, saving, pasting, or calculating. These functions are known as processes, essentially activities that can only be articulated using verbs. It is imperative for the requirement engineer to accurately identify and define these processes to ensure the successful implementation of the requirements. The next part defines the system activity, which can be categorized into three main types. The first type is autonomous system activity, where the system operates independently to perform processes without external intervention. This type exemplifies the system's ability to function autonomously without the need for user input. The second type of system activity is user interaction, where the system provides services that require user involvement. In this scenario, the system interacts with users to execute processes catering to their needs and preferences. The third type of system activity involves interface requirements that dictate the system's behavior based on external factors, such as interactions with third-party systems. In this case, the system may remain passive until triggered by an external event, demonstrating its reliance on external stimuli to initiate processes. Some process verbs require one or more additional objects to be considered complete. For instance, the process verb print requires additional objects to be considered complete. These objects include information on what is being printed and where it is being printed. Without specifying these details, the printing action remains incomplete. The action becomes more precise and effective by updating the requirements template for the process verb print with the necessary information. Knowing what is being printed and where it is being printed ensures that the intended output is achieved accurately. And the last part adds a condition. Requirements typically document functionalities performed or provided under specific logical or temporal constraints. To distinguish between these conditions, the temporal conjunction, as soon as, is used for temporal constraints, while the conditional conjunction, if, is used for logical constraints. And the conjunction when should be avoided as it lacks clarity in specifying whether a condition is temporal or logical. Let's summarize. Using the temporal conjunction, as soon as, helps to indicate time-sensitive requirements specifying when a particular action should be triggered. On the other hand, the conditional conjunction, if, is employed to outline logical conditions that must be met for a specific functionality to occur. And it's crucial to avoid using the conjunction when in requirements to prevent ambiguity. Another view of the structure with practical examples is presented on the screen. It's crucial to include certain key elements in the structure of requirement statements for clarity and completeness. These elements, such as the system, degree of obligation, and process, are not just important, they are the backbone of a well-defined requirement statement. Neglecting these could lead to an incomplete understanding of the requirements. While other elements are not mandatory, They provide a more detailed perspective on the specified case, thereby enhancing the overall understanding of the requirements. The level of detail and abstraction in requirement statements is influenced by various factors such as project requirements, team proficiency, and time allocated for specification. It's not just a suggestion, but a necessity to tailor the level of detail to suit the project needs and the development team's expertise. Striking a balance between specificity and comprehensiveness is vital to ensuring the requirements are clearly defined and actionable for all stakeholders. Let's look at a few examples to be more precise. The first one is, the system must allow blog visitors to sign up for the newsletter by leaving their email. In that case, we have a system, obligation degree, which presented with the word must. Also, we specify the required process, which consists of allow blog visitors to sign up. Next, the object newsletter, and finally some additional information with the statement of condition by leaving their email. The second one is, the system should allow users to verify their accounts using phone numbers. This example is specified according to the provided template. It contains the system, obligation degree presented with the word should, the required verification process, and conditions. Compared with the first one, we are using should instead of must, which means a strong desire for compliance, but is not mandatory. Let's look at one more example. The system will send a confirmation email to the user after they have booked a flight. With that example, we are providing a smooth obligation with the word will. That means that this requirement is less required from the project team and might be reprioritized later. As you may have noticed, all three examples contain a similar definition structure. Such an approach simplifies the navigation and reading process for any project member. Moreover, such a structure focuses on the fields recommended to be presented with a fully specified requirement, which would help test them. You may notice that these requirements are too templated and formulated in a free narrative form. This is a good approach that leads to a common understanding of requirements by other engineers, developers, project and product managers, or other involved stakeholders. Thank you for your attention and see you in the next modules.